Paper one. Paper two.
Paper two, special relativity, where he
just that.
Just that. So a lot of times, the theory of relativity became this real colloquial thing. Everything's relative, and it became invested in society. I often say it could have been called the theory of absolutism, because what Einstein really had done is he had adhered to the absolute limit of the speed of light. He took that more seriously than anybody else was taking it at the time. In fact, people were struggling to get rid of it, this idea that the speed of light was a constant. And they were doing everything they can to dethrone that concept, which really wasn't taking hold.
So it's not just that it's a constant. It's that it's a constant no matter how, when, or where you measure it.
Absolutely.
You're getting the same answer.
That's right.
Even if you're moving and the light is moving relative to you, you measure the same speed of light.
Right.
Which doesn't exist for anything else.
That's insane.
Yeah.
It's an insane concept.
It's
Two
crazy.
cars coming at each other are coming at each other faster than if one of the cars stops.
Right.
Okay, but that is not true at the speed of light. You run at the speed of light. Maybe you're running slowly. Maybe you're running near the speed of light yourself. It's still coming at you at the speed of light.
Right.
It is chilling, strange, seems impossible.
So I think a simpler example is I'm on the front of a train. Let's say the train goes 60 miles an hour, and I throw a ball 40 miles an hour. Can I throw that fast? Probably not. Okay.
I know I definitely can.
I think you can do anything, Neil.
I can do anything.
I think you can do anything.
I throw it 40 miles an hour in front of the train. You're standing at the platform. How fast is the ball passing you? Ding, ding, ding.
Right. Is it not adding the two up?
Yeah.
So it's 100 miles.
100 miles an hour.
Should be. I mean, that was
but
common
if I'm
experience.
on the front of the train,
I mean, I'm not calculating the speed. I'm worried that Neil deGrasse Tyson's on the top of a train throwing the ball, and I'm very confused.
So now I'm on the same 60 mile an hour train. I shine a beam of light, and you measure the beam of light going by you. It is the same speed of light.
We don't add the train.
We don't add the train.
We don't add the train.
That's That's batshit crazy.
It is crazy, and Einstein meditated on this for so long, and there's kind of a simple way to see. He said, well, what is speed? It's the distance you cover in space divided by the time elapsed. So it has to do with space and time. I mean that's a huge leap already. And he said, I'd rather that your measures of space and time are relative than give up the absolute nature of the speed of light.
Wow.
So
your very measuring stick changes.
Right.
Relative to the other observer.
So that you get the same answer.
So that you get the same answer.
That's not the measure stick and your rate the time ticks. That's crazy.